Good afternoon, everyone. This session is going to go over a few parameters of the course, and then we're going to talk about a bit of Module 1. I will try to keep the video a little shorter than like a full hour session. We're not going to do it for an hour, but hopefully you'll be able to revisit this and find out some good information. A couple of little pieces of information general to the online course this semester. So I'm just, for recording purposes, going to say the date here. It's February 23rd, 21. And in this particular semester, there's no diploma. So the reason that I mentioned that is that it is an optional thing that you can take if you're interested in taking it. But if you decide not to take it, that's fine. It won't, be counted. And to that end, if you're a student that's highly motivated and wants to roll through this course quicker than finishing in June, you're by all means encouraged to do that. I do try to make sure my marking is pretty up to date. Like right now at this second, I have one thing in this class to mark, 2 in Math 30-2, and 2 in Math 31, and then I'm caught up. So I do try to fairly regularly keep the marking up. So keep that in mind. If you're a real keen math student and you really want to roll ahead, that's totally fine. Another thing to quickly mention, since this is kind of our beginning tutorial, is that as you're going through the course, there are a few things that you're allowed to get help on and a few things you're not allowed to get help on. So if you have a tutor, which I see a few of us do, you get help on any lessons, any lesson quizzes, anything in the textbook, any of those items. And then you don't get any help like from outside people. I'm always here to help on the assignments, or if there's a project assigned, which there's a couple projects there. But again, you can always ask me for help. And I'll just caution you, be really careful about this, just because there can be some serious ramifications if you go to a tutor and get help with these things without kind of following the rules. Don't worry though, if you're at all worried about things, just reach out to me and ask, and I'll help sell you through so that you're not worried about, breaking any rules and that kind of thing. So today, for the most part, the thought is that we'll go through some transformations so that you have a little bit of a guide. I'll try to hit the highlights in one session. I can't possibly go through, all of the important pieces of transformations, but I can try to give you kind of the highlights of things. So this tutorial now would be best viewed after you had done at least the first 3 or 4 lessons. So if you haven't done that, you might want to just back out of the video, go on your way and do those, and then maybe come back and revisit this as a bit of a background. You're certainly welcome to watch it beforehand. But this module 1 in our course, is entitled Transformations of Functions. And I personally think this is an excellent unit to start this course with, because once you learn how to transform the few functions that we talk about here, it the information translates into the next module. So it's a nice way to start the course. And so what it involves doing is learning how you take any function, and I'm just naming the function f at x. We name functions f, g, etc., and transforming it into an overall function that looks like this. And each of these letters here that I'm going to highlight, the A, the B, the H, and the K, do specific things to a graph. So that's what I want to start as a bit of a summary. So the A, it will vertically stretch and vertically reflect. Okay, so vertically stretch and vertically reflect. I'll write that in actual words this time, but normally then I'll just kind of back off to the shortened version. So vertically stretch and vertically reflect. And then I'm going to go to K, just because it's the other vertical one. It's our vertical translation. Okay, so this is the vertical translation. And we find when we do the translations and the transformations on functions, that everything vertical is really quite straightforward. Normally students don't get kind of hung up on them, but everything horizontal is a pain in the neck. Okay, so I want to leave those till second. So the B factor here, this is a horizontal stretch. Okay, but we have to be careful that we stretch it by a factor of 1 over b, the reciprocal of the number that's in there. So that's what I'm talking about, to be kind of a pain to watch. And vertical reflection, I guess, sorry, not a vertical reflection, horizontal reflection, if the b is negative. And I should say this here, if the a is negative. Which again, if you've gone through some of the lessons, then you've seen that kind of information. And the last fellow that we have not talked about, the H value, is the horizontal translation. And again, as I mentioned, everything horizontal is a bit of a pain. We have to be careful that we change the sign. So that can look pretty intimidating if you haven't engaged and kind of done it piece by piece, because the lessons break out and do the translations first, and then they do the stretches, and they do the reflections, and then they put it all together. And so you don't want to start kind of putting it all together. I think it'll get a little bit too mucky and hard to deal with. Assuming that you have done some of the background work, one thing that is very, very helpful when you're trying to figure out how to graph something is to use something called mapping notation. And mapping notation helps us to figure out where a point will move from and where it will end up. And so if we have a point on an original curve, any point x comma y, the mapping notation, we take kind of all that information up there and put it into a little bit of a equation. To find the new x value, it's 1 over b times x plus h. That indicates that we're taking the reciprocal of the stretch factor and we're changing the sign on the translation factor. And then again, vertically, everything is sort of normal, quote unquote. And so it's just ay plus k. And so I find this piece of information not highlighted all that much in the course and in other features like the textbook and whatnot, but I really like this to be a method for finding out how to move points around. So I'm going to do a question here that's very similar to an assignment question. I won't do an exact replica of it, but if you're at the assignment, you want to come back and watch this again. I'll even pull the assignment up. Give me a second here so that I can tell you kind of which one exactly it's going to be like. So this one that we're going to mess around with is going to be similar to 4A part 3. Okay, so I'm going to do one kind of similar to 4A part 3. And it's going to ask us to find the mapping notation and then move a particular point from the original curve onto the new curve. Okay, so let's rock and roll and do that. So here's the question. So given that y equals f at x is transformed into y equals minus 2 f of 1/3 x plus 6 minus 1. Here's part A. State mapping notation. And then part B, I'll make up a point and we'll figure out where it moves. Let's do this, stating the mapping notation. Now, I brought something up, kind of troublesome here, that I wanted to make sure to point out. If we kind of just, I'm going to zip back up to the top of the board. You see that we have double brackets up here. We have a bracket. I'm going to put a different color, and then a bracket, and then a bracket, and a bracket, double brackets. The H value has to be common factored out of the B value. So if you look at what I gave you here as a little bit of trouble down here, I have not factored the A value, which is this guy, or sorry, the B value and the H value. There's a problem. We need double brackets there. So before you start this one, and before you start 4A part 3, which is the one that I'm kind of alluding to, you will want to rewrite this in the right format. So we will go and have -2 here, F, and we're going to factor out a 1/3. So you're just going to have to be careful that you factor out 1/3. That means you're dividing. I don't know that 6 was the best number to put there, but this will turn into being 18. Okay, so just pause and think about that for a second. I can kind of do a little break off here just to make sure in case anyone's reading this and going, good Lord, where did she get that? So if we had originally here, we had 1/3 x plus 6, and I'm going to factor out a third. That means I'm dividing by a third is what I'm doing here. That's what the math is. And so think about your fractions. That means multiplied by the reciprocal, and that's where the 18 comes from. Okay. Pretty ugly number I gave there, but nonetheless. Now we can do our mapping notation, and then we can do part B where I'll throw a point in and then we'll find the new location of the point. Okay, so the mapping notation is XY moves to, and again, just follow what's in that box up above. Okay, so it's going to be 1/b. So 1/1/3. Let's write it that way and then we'll simplify. 1/1/3 x. Change the sign on the H, so -18, and then everything on the Y just is totally normal. So -2y minus 1, so nothing weird there. So a better way of writing this mapping notation is 3x, because 1 divided by 1/3 is 3, take away 18, and then -2y minus 1. So there's our mapping notation. Okay, so what that means is if I then give you some points on the original curve, you can easily just dump them into this little mini equation and find out the new location. So let's do that as part B. So let's say that 1, 5 is on the graph of y equals fx. So it's just kind of the original one. State the new location for part A. Okay, so I don't have to rewrite that whole thing. So simply all we do is we write down our mapping notation, 3x minus 18, comma, -2y minus 1. And I love the fact I can kind of change my colors. And so the 1 is going to go in here like that. And then the 5 is going to go in there. And then it's pretty simple mathematics to figure it out. So we get 3 multiplied by 1, take away 18 as our new x coordinate, and -2 multiplied by 5, take away 1. And so then we get 3 minus 18, minus 10 minus 1. And so our new location is -15 and -11. So I do find that mapping notation really gets us kind of out of a jam. If at all you can use it. And this particular question brought up a whole bunch of good things. Okay, like good things in the respect to that whole bunch of those little tricky things that come up in this module. So let's just go back up and kind of revisit. There's our mapping notation. I gave us this question and pointed out to us that there was problems here with no double bracketing. So we had to be cautious to factor out the -1/3. And then as we put it back into the mapping notation, we had a division of a fraction. So some really good tricky type things that came up there that can come up as you're going through questions. So I thought I would just point those out. Okay. Yeah, I'm going to go and have a little quick sneak peek again at the assignment and see what else we might want to highlight. As I say, I don't want this recording to be too long so that you're sitting here forever kind of watching it, but trying to make it somewhat useful for you. What else can we mess around with? Of course, I can't do the assignment questions per se. One other thing that I think would be useful for us to talk about is inverses. I think that would be something that's on lesson 5. So this, and I'm not saying I'm doing justice to doing the entire module here, trying to point out some of kind of the bigger ideas, but let's for a moment talk about lesson 5. Oops, let's maybe just move down here. We have a nice clean piece of board. There we are. Okay. So you have experience from Math 20-1, if that's where you came from. If you decided to go through the -2 and go for 30-2 up, you might not have a lot of experience in inverses, which is totally fine. I'm going to show it to us, kind of pretending you have no background. So inverses are when you interchange the x and the y. So let's just write that down. To find an inverse, you interchange the x and the y. Then what we try to do, if possible, most of the time it's possible with the ones that we're asked to do, then we solve the inverse for y. Let's just kind of take a little shot at something. Okay, so we'll keep it fairly light to start. Let's say that we've got y equals 2x minus 1. Hopefully you can identify that that's a linear function. It's a line because we've got no exponents and whatnot. And if I ask you to find the inverse of that, then we interchange the x and the y. So it reads x equals 2y minus 1. And then, as I mentioned up above there, we want to solve the inverse for y. So this is not terrible math. I'll do one with quadratics. It gets a little hairier. So we would add 1 to both sides. So we get x plus 1 equals 2y. And then divide both sides by 2. Now I'm going to put the y on this side just because I kind of like to have the y on this side. And you could rewrite this. You could have it at x plus 1 over 2, or you could also write it as 1/2 x plus 1/2 if you wanted to break it up. I'm not particular. If it's a multiple choice question, obviously if you come up with one of those answers, it'll be as one of the options. And then there's something called inverse notation that you might want to take note of. Once you have it solved for y, you can replace it with inverse notation. And what we do is we take the y out and we put this f to the -1 of x. Now, it's not like the -1 power. It's just indicating inverse. I don't really know why. I mean, I don't make up all these rules and all these things, but this is the function notation we use for inverses. And that would be our inverse. Okay. Something else to mention about inverses, and I might just kind of go back up to the top and throw it in here. When we interchange the x to the y and the y to the x, the graphical interpretation is that we reflect across the line y equals x. Okay, so that's something else just to kind of keep in mind. So if we were to graph these two items, we could do a quick little sketch. I'm not too worried about making it too perfect. This first one here would be down at -1. You might remember how to graph lines. You have a graphing calculator, you can totally use that. You go up 2, you go over 1, you go up 2, you go over 1, and you get this line, something like this. Now, if we kind of dot in, so let me see. Over 1 up to, let me do a little bit better. You know what? Why don't I take a moment? I think I can just put a piece of graph paper to indicate this might be a little easier to have a piece of graph paper here. So I think I can quickly go and find a piece of graph paper here and throw it into our recording. Just give me a second to, yeah, there we are. This is going to be much better. Okay, so let's move this guy up here. Come on. There we are. And then we'll just make it a little bit bigger. Come on. Trying to move just it. Well, maybe not. A little too small is all. There we are. That's better. Okay. Okay, anyway, it won't allow me to move, but that'll be much easier. Okay, so let's graph on that. We'll be able to get a little bit more detail. So we have a -1 as our y-intercept. We go up 2, we go over 1, we go up 2, we go over 1, we go down 2, we go back 1, etc. And then we can connect the dots here. So that'll be a little bit more Okay, so there's the original one. Now, I think it's important that we put the reflection line of y equals x. So I'm going to graph it, and it's going to be here and here and here. It's going right diagonal like this, straight across. So this is the actual reflection line, like that. So that's y is equal to x. And then if we graph the 1/2 x plus 1/2, I'll do it in yet a different color. I'll do it in green. I'll indicate it in green by putting a box around here. We start at plus 1/2. This isn't really the most wonderful one, but nonetheless, we go up 1, go up 1/2. Let me see. Go up 1, go over 2. There we are. There's our go up 1, go, and we're just going to get this kind of generally like this, go down 1. So it looks like this. And that's our inverse, 1/2 x plus 1/2. This gives rise to another little piece of information that we should talk about called the invariant point. All right, so I'm going to ask kind of generically, do you know what an invariant point is? So an invariant point is a point that does not move when transformations are applied. So we talk a little bit globally about, because we've sort of got this picture kind of nicely done now. If we talk about all the different types of transformations that you're responsible for knowing, translations, reflections, stretches, and inverses, we should think about when we're going to have invariant points, possibly, and when we're not. So let's talk about or think about translating. If we're just sliding things around, we're never going to have invariant points because the entire graph is going to slide around. Okay, so we could just note that there are no, I'm going to call it IPs when we have translations present. But we definitely have invariant points when we're doing any kind of reflections or stretches or inverses. Okay, so there are invariant points for stretches, reflections, or inverses. And it might be good for us to just note here, they are always on the reflection line. So in this course, we're asked to reflect across the x-axis vertically, across the y-axis horizontally, and do the inverses across y equals x. So they're always going to be either on the x-axis, the y-axis, so I put that in the opposite order, but anyway, the x-axis, the y-axis, or the line y equals x, depending on what it is that you're doing in the question, okay? So if you look at the question that we're talking about, we have an invariant point right there. Okay, when the x value and the y value in this particular question are exactly the same, that's where it's going to touch. Okay. Now, could we figure it out? Is it 2, 2? Does 2, 2 work here? Let me see. 2 in here, 2 times 4. No, it's not 2, 2. I didn't draw it carefully. That wasn't the whole point of this example. So we won't worry about exactly where it is. We'd have to do a very careful analysis, but do note about invariant points. And the last question that I wanted to talk about before I wrap up is, again, doing a bit more inverses, but not with a linear function, with the quadratic. Because sometimes I find that students get a little bit lost on the quadratic. So say that we start with y equals, say 3x squared plus 2, and we're asked to find the inverse equation. Not terribly hard math, but kind of tricky. Lots of the things in math are not terribly hard, just, again, just kind of tricky. So we interchange is the word I'm trying to come up with, the x with the y and the y with the x. And then we solve for the y. So we get x minus 2 equals 3y squared. divide both sides by 3. Again, I don't like when the y gets stuck on the right-hand side, so I'm going to move it back over. So we get y squared equals x minus 2 over 3. And then we square root it. And we get plus or minus the square root of x minus 2 over 3. Now, interesting enough, you know how I gave you this notation, inverse notation here? Your inverse has to be a function before you're allowed to use that notation. So let's just think about what this looks like. If we, and I'm just going to do just a general graph here. I'm not even going to worry about how perfect it is. This is up at 2, and it opens up and is narrower. Hopefully from your grade 11 work, wherever you came through, -1 or -2, we sort of know that's what it looks like. And the inverse is going to be reflected across this diagonal line that we were talking about. So it's going to look like this. So is that a function? Okay, again, some more math from grade 11. A function can be tested by doing the vertical line test. So the vertical line test, and I apologize for my handwriting. I'm trying to make it as clear as possible. I'm writing on my actual whiteboard. The vertical line test says it can only cross once for it to be a function. So this is not a function. Therefore, we can't use that specialized notation, and we would just leave it like that. Okay. Okay, now that's about what I wanted to cover in this particular recording, because again, I don't want you sitting here having to watch too much. So I'm going to wrap up the recording, and then I'm just going to ask some questions of those that are here. So to stop the recording.